Hello friends, welcome to my channel Indian Code Guru. In today's video we can talk about big data architecture, but first of all, if you are new in my channel, please do subscribe to my channel. Let's begin. A big data architecture is designed to handle the ingestion, processing, and analysis of data that is too large or complex for traditional database systems. The threshold at which organizations enter into the big data realm differs depending on the capabilities of the users and their tools. For some, it can mean hundreds of gigabytes of data, while for others it means hundreds of terabits. As tools for working with big datasets advance, so does the meaning of big data. More and more, this term relates to the value you can extract from your data sets through advanced analytics, rather than strictly the size of the data, although in these cases they tend to be quite large. Over the years, the data landscape has changed. What you can do, or are expected to do, with data has changed. The cost of storage has fallen dramatically, while the means by which data is collected keeps growing. Some data arrives at a rapid pace, constantly demanding to be collected and observed. Other data arrives more slowly, but in very large chunks, often in the form of decades of historical data. You might be facing an advanced analytics problem, or one that requires machine learning. These are challenges that big data architectures seek to solve. Components of a big data architecture. This picture is show how big data architecture works. We can discuss each and every component one by one. Data sources. All big data solutions start with one or more data sources. Examples include application data stores, such as relational databases. Static files produced by applications, such as web server log files. Real-time data sources, such as IoT devices. Data storage. Data for batch processing operations is typically stored in a distributed file store that can hold high volumes of large files in various formats. This kind of store is often called a data lake. Options for implementing this storage include Azure Data Lake Store or blob containers in Azure Storage. Batch processing. Because the data sets are so large, often a big data solution must process data files using long-running batch jobs to filter, aggregate, and otherwise prepare the data for analysis. Usually these jobs involve reading source files, processing them, and writing the output to new files. Real-time message ingestion. If the solution includes real-time sources, the architecture must include a way to capture and store real-time messages for stream processing. This might be a simple data store, where incoming messages are dropped into a folder for processing. However, many solutions need a message ingestion store to act as a buffer for messages, and to support scale-out processing, reliable delivery, and other message queuing semantics. Stream processing. After capturing real-time messages, the solution must process them by filtering, aggregating, and otherwise preparing the data for analysis. The processed stream data is then written to an output sink. Machine learning. Reading the prepared data for analysis from batch or stream processing, machine learning algorithms can be used to build models that can predict outcomes or classify data. These models can be trained on large datasets, and the resulting models can be used to analyze new data and make predictions. This can be done using analytical data store. Many big data solutions prepare data for analysis and then serve the processed data in a structured format that can be queried using analytical tools. Analysis and reporting. The goal of most big data solutions is to provide insights into the data through analysis and reporting. Orchestration. Most big data solutions consist of repeated data processing operations, encapsulated in workflows that transform source data, move data between multiple sources and sinks, load the processed data into an analytical data store, or push the results straight to a report or dashboard. Thanks for watching. Don't forget to subscribe to my channel. Hello friends.